So imagine you are, well, just picture this for a second. You are standing right next to this massive state-of-the-art rocket on the launch pad.
Okay, I am picturing it.
Right. And the engineers, they just keep pouring higher and higher octane fuel into the tanks, and the thrusters ignite. And I mean, the raw power is just absolutely undeniable.
Oh, yeah.
But instead of launching smoothly into the stratosphere, the entire chassis just starts violently shaking itself apart. Like the pressure is way too high, the materials are stressing, and you suddenly realize the underlying infrastructure just wasn't built to handle this much thrust.
Wow, yeah. That is a phenomenal visual.
What?
And honestly, it's probably the most accurate way to describe the current state of artificial intelligence right now.
Right.
I mean, we are basically watching an entire ecosystem
Yeah.
that is practically at war with its own momentum.
Exactly. It is just grinding friction everywhere you look. And honestly, that is exactly what we are getting into on today's deep dive for Thursday, July 2, 2026.
It's a big one today.
It really is. So we are so glad to have you with us as we tear into today's source material. We are looking at the latest tech digest from Aaron Rose's Tech Reader blog.
Yeah, which covers, I mean, just a massive tidal wave of breaking news across the AI space.
Huge updates. But we are also pulling in some really fascinating historical context from his older hardware tinkering posts. Because, you really need to see the bottom of the stack to understand the top.
You really do.
Yeah.
I mean, you can't comprehend why multi-billion-dollar enterprise deals are failing today without understanding what is actually happening down in the trenches, right?
Yeah.
With the people who are actually writing the code.
Exactly. So our mission for this deep dive is to dissect this massive friction happening right now. We are looking at this crazy three-way collision.
The three big pillars.
Right. Staggering new model capabilities, absolutely brutal deployment costs, and a frantic scramble for global regulation that is just catching every developer right in the crossfire.
It's a mess.
It really is. Okay, let's unpack this. And I want to start with the capability side of the equation because, we just have to talk about Fable 5.
Oh, we absolutely do. I mean, Fable 5 just fundamentally shifted the goalposts. It completely changed what an AI model can do without, a human sitting there holding its hand.
Yeah, Fable 5 just secured this massive independent benchmark win. So the Center for AI Safety, or CAS, along with Scale AI Labs, they just released their updated remote labor index results.
And the numbers are just wild.
Totally wild. Fable 5 hit 16.1% on 240 real remote work projects, and that is spanning 23 different professional domains.
Right.
Plus, it took the #1 spot on Cursor Bench, and it even produced the best HTML5 Canvas physics demos in an atomic.chat coding contest, which was a blind contest, by the way.
What's fascinating here is the specific nature of that remote labor index. Like, we really need to pause on how this fundamentally changes the whole testing game.
Yeah, break that down for us.
Well, for the longest time, AI models were graded on these highly synthetic academic tests,
Like, can it pass the bar exam?
Exactly. Or can it solve a really obscure high school logic puzzle? But the remote labor index, it doesn't care if the model is mathematically smart in a vacuum. It asks a purely economic question.
Which is what matters to businesses.
Right. It asks, would a real client actually accept and pay for this deliverable as a finished product?
So it's basically an acceptability benchmark. It's like handing the AI a really messy Jira ticket, walking away to get coffee, and seeing if the code it kicks back actually compiles and solves the problem.
Precisely. So hitting 16.1% across 240 real-world projects, that means that in over 15% of highly complex professional tasks, the AI produced work that a manager would look at and say, great, invoice approved.
Completely unsupervised.
Completely unsupervised. That is a massive grounded signal for the enterprise market.
But, and this is catastrophic, but for a lot of companies out there right now, there is a really brutal catch.
Always a catch.
Right. When you look at the developer reactions in the source, they are heavily divided. Like, they are getting these highly capable agentic sessions, sure, but they are slamming into guardrail friction, arbitrary weekly usage limits, and a severe, severe cost multiplier.
The cost is the real killer here.
It is. Fable 5 costs approximately 6 times more than Opus 4.8.
6 times the cost. That is not a marginal increase. That's a different stratosphere.
No, it's insane. Think about it like this. If I run a mid-sized business, it's like I just found this genius freelance contractor who does flawless work, needs zero management, But they charge 6 times my entire department's operating budget.
Right. It doesn't even matter how good they are at that point.
Exactly. It fundamentally blows up the Q3 return on investment calculation for literally any enterprise trying to adopt this at scale.
It completely shatters the financial model. And, to truly grasp how absurd this cost multiplier is at the frontier of AI, we actually have to look at the other extreme.
Oh, the edge computing stuff.
Yeah. Let's pull in those older Aaron Rose posts about hardware tinkering at the edge. Because right now you have developers desperately trying to run AI locally on an 8 GB Raspberry Pi 5.
Which, for anyone who hasn't seen one, is literally a credit card-sized computer that costs, what, about $80?
Right around there, yeah. And the Pi 5 is an absolute beast for its size. I mean, it has an 8 GB RAM option, a quad-core 2.4 GHz Cortex A76 processor.
That's a lot of power for a tiny board.
It's a huge leap for edge computing. But, as the source details, raw specs don't magically make AI run smoothly. Without specialized hardware acceleration for deep learning, running these models locally is just agonizing.
The contrast in developer mindset here is just jarring to me, because on one end you have enterprises bleeding millions to pay a 6x premium for Fable 5 in the cloud.
Yeah.
But on the other end, developers are fighting for literal megabytes of memory. The blog highlights this Diet Pi versus Raspberry Pi OS Lite showdown. Developers are agonizing over which minimal operating system strips out just a few more background processes just to free up enough RAM to run a tiny language model.
They're completely scraping the bottom of the barrel for resources.
Yes. Or they are typing in obscure terminal commands like connect doctor just to troubleshoot stun network peer-to-peer connections for their headless servers.
It's a completely different world.
And actually, let me pause there for a second, because stun networks are one of those things that sound incredibly intimidating if you aren't a network engineer.
It is a really heavy piece of jargon, yeah. But the concept is actually quite simple. So StunN stands for Session Traversal Utilities for NAT.
Okay.
Imagine you and I are in 2 different office buildings, right? And we want to talk, but neither of us knows the other's phone number, and both of our building receptionists refuse to pass messages.
Basically a corporate nightmare.
Exactly. So a stun server is basically a guy standing in the street between our buildings. We both yell out the window to him, and he yells back to tell each of us where the other one is looking so we can finally establish a direct line of sight.
Oh, okay. That makes sense.
So when developers are running connect doctor, they are basically begging the network to just let their tiny credit card-sized computer communicate through their home router's firewall so they can access it remotely.
Wow. So you have this ultimate dichotomy. The developers at the edge are pinching pennies on memory and fighting firewalls. While at the frontier, the cloud compute costs are so astronomical they are breaking corporate budgets.
Exactly.
And this perfectly explains why so many massive corporations are currently stalling out in what the industry calls pilot purgatory.
Yeah, that's a very real place right now.
They test an AI tool, it works beautifully in a vacuum, but then they realize they can't afford to scale it, or their IT team just lacks the expertise to integrate it. Which I think brings us to how Amazon is trying to brute force a solution to this.
And brute force really is the only way to describe this move by AWS.
It's so aggressive. So AWS just announced a $1 billion forward deployed engineering organization. They call it an FDE.
$1 billion.
$1 billion. And they are essentially taking their absolute best frontier technical specialists and parachuting them directly into their enterprise customers' operations to design, build, and ship production agentic AI systems.
It is massive.
But what does this all mean? Because I have to throw that right back to you. Historically, that is just not how Amazon Web Services operates. Their whole brand is being a self-serve platform.
Oh, it is a massive structural pivot. You're completely right. AWS's entire historical business model was essentially, hey, here's the raw cloud compute. Here is the API documentation. Have your IT team figure out how to build the app.
Exactly. Just read the docs.
Right. But a $1 billion FDE unit means AWS is admitting that strategy is dead when it comes to generative AI. Selling raw materials just isn't enough anymore.
Because it's too complicated.
Yes. The integration, the data governance, the organizational complexity of deploying AI agents is just completely overwhelming their clients. Most of these pilots fail to produce any business impact. So by embedding an agentic-first strike force to compress deployment from months down to days, AWS is trying to leave organizations self-sufficient, rather than dependent on AWS to hold their hand forever.
But wait, I mean, isn't this AWS basically waving a white flag? Aren't they admitting that their underlying infrastructure has just become way too complicated for a standard corporate IT team to actually use?
That's a fair point.
I mean, if I buy software and the company has to send a specialized team of engineers to my office to make it work, the software isn't exactly user-friendly.
I wouldn't call it a white flag, but I would absolutely call it a reality check. I mean, they are tired of watching their clients' AI pilots stall out.
Yeah, that makes sense.
A standard corporate IT team is built to maintain databases and manage employee laptops.
Yeah.
They do not have the specialized knowledge to build agentic workflows that can reliably execute complex business tasks.
Right.
And we are seeing other giants make similarly aggressive moves right now, too.
Oh, definitely. Just looking at the quick hits from the digest, Cisco is deploying AI agents to all 90,000 of its employees right now.
90,000 employees.
Yeah, and it's not just for drafting emails. Cisco's finance teams are already using agents to draft MD&A sections for their financial reports.
Which is stunning.
It really is, because the MD&A, the management discussion and analysis section, that is where executives actually have to explain why the financial numbers look the way they do. It requires deep contextual judgment, not just copy-pasting spreadsheet data.
Trusting an AI to draft executive financial context shows an immense, almost unbelievable level of confidence in the tech.
Meanwhile, Meta's stock just jumped 9% purely because they signaled a pivot to sell their excess AI compute capacity through a brand new cloud business.
Which really tells us that the capital flowing into the hardware layer is just staggering. But, while AWS and Meta focus on the plumbing, the model builders themselves are just flooding the market with an unprecedented wave of product updates. It is creating so much acceleration.
It is a literal tidal wave. And earlier I was just looking at the sheer volume of updates in the digest and getting kind of dizzy.
It's hard to keep up.
It is. But let's actually run down what this money is buying, because a few of these updates fundamentally change how software is built. Anthropic just shipped Claude Code 2.1.198.
That's a big one. Chrome general availability, right?
Yes, Chrome GA, a new /dataviz skill, but the big feature, background agents with auto-commit capabilities.
And that is a major threshold to cross. Auto-commit means the AI isn't just suggesting a block of code and waiting for a human developer to click approve.
Right.
It is actively analyzing the code base, writing the fix, and committing it directly into the project repository entirely on its own. It is acting with true agency.
Exactly. Then you have Perplexity using Fable 5 as an orchestrator for complex workflows. And OpenAI is eyeing mid-July for the general availability of GPT 5.6, which encompasses their Sol, Terra, and Luna models. But right now, it's locked in a government-gated preview for just about 20 authorized organizations.
Okay, keep a pin in that government-gated preview part, because that is going to be the most critical piece of the puzzle in a few minutes.
Duly noted. Moving down the stack, xAI launched Voice Agent Builder for phone agents at just 5 cents a minute. Google launched Gemini Spark on macOS for Ultra subscribers, Gemini Omni Flash for video generation, and their GenKit agents with a Cloud Workbench VS Code extension.
Just relentless releases.
It doesn't stop.
Yeah.
The GitHub Copilot browser tools are GA and VS Code. NVIDIA released Nematron Labs 2 Tower, boasting 98.7% quality and 2.42x throughput. They also dropped generative pre-trained controllers specifically for physical AI motor control, trained on over 600 hours of motion data.
So they aren't just generating text anymore. They are generating the precise physical movements for robotics.
Exactly. And then Z.AI launched Z-Code, which is a GLM 5.2 environment starting at $16 a month. And I have to stop and ask you about this next one. The source mentions Fireworks AI is hosting a massive 743 billion parameter MOE GLM 5.2 model.
Ah, yeah. MOE.
Right. I keep seeing this acronym everywhere right now. MOE, mixture of experts. What is actually happening under the hood there?
It's a great question because it sounds incredibly dense, but the concept is actually very intuitive once you break it down.
Okay.
So historically, large language models were monolithic. If you asked the model a single question, every single one of its billions of parameters would fire up to calculate the answer.
Which sounds incredibly expensive and slow.
Exactly. It's like using a sledgehammer to crack a peanut. A mixture of experts or MOE architecture changes that. Think of it like a massive hospital.
Okay.
If you walk into a hospital with a broken arm, you don't need to consult the cardiologist, the neurologist, and the oncologist.
Right, you just need the bone doctor.
Exactly. The hospital routes you directly to the orthopedic specialist. And MOE model does the exact same thing. It is made up of dozens of smaller, highly specialized subnetworks, which are the experts.
Ah, I see.
Yeah, so when you give it a prompt, a routing algorithm instantly decides which 2 or 3 experts are best equipped to handle that specific task, and it only powers up those specific networks.
Wow, so it drastically reduces the compute cost while maintaining the massive scale of the overall model.
Precisely. It's how you get a 743 billion parameter model to run efficiently enough to actually offer it as a commercial service.
That makes so much sense. And the scale of capital funding all of this infrastructure is just breathtaking. Together, AI raised $800 million at an $8.3 billion valuation. Abu Dhabi's MGX fund raised $49 million. 12 labs secured $100 million for video search. ByteDance is building a $39 billion data center in Brazil, and SpaceX is joining the NASDAQ 100 on July 7th.
The money's just flowing.
It's everywhere. But, okay, here's where it gets really interesting. Buried in all those product updates from Anthropic is a single detail that completely changes the tone of this massive open market acceleration.
Yeah, this is wild.
Anthropic actually had to pull back a specific Claude Code feature following intense internal controversy. It was a location tracking feature explicitly designed to identify developers who were either physically in China or affiliated with Chinese AI labs.
Yes, and that right there is the friction point where technology slams into geopolitics.
And I want to be very clear here to our listeners. We are not taking a stance on Anthropic's internal politics or the geopolitical tensions with China or UX trade policy.
Right, we're just looking at the facts on the ground.
Exactly. We are just impartially highlighting how this geopolitical friction is now creeping directly into everyday developer tools.
And if we connect this to the bigger picture, it proves that building frontier AI is no longer just a computer science problem. It is a national security challenge.
Yeah.
You have this intense tug-of-war happening. On one side, there's the open ecosystem trying to accelerate globally, sharing code and driving down costs. But on the other side, you have governments terrified of losing technological supremacy, imposing location tracking and gated access.
It's a huge clash.
It is. And this sets the stage perfectly for the final collision we really need to talk about today: the looming battle over global governance.
Which brings us to the United Nations. So the UN Secretary General's office just released a preliminary report from their independent international scientific panel on AI.
Which is a massive panel.
Yeah, it's a 40-member global panel, and it is co-chaired by Yoshua Bengio and Maria Ressa.
And we really have to look at those two names for a second because it lends immense credibility to this panel. Yoshua Bengio is quite literally one of the godfathers of deep learning. He won the Turing Award for his foundational work on neural networks.
He's a legend in the field.
And Maria Ressa is a Nobel Peace Prize-winning journalist who has spent her entire career fighting digital disinformation. So you have the ultimate computer scientist paired with the ultimate defender of information integrity.
And their warning was stark. The panel concluded that the rapid, unchecked spread of AI is highly likely to actively worsen global inequality.
Yeah, it was not an optimistic report.
Not at all. They highlighted severe risks surrounding deceptive AI behavior, the collapse of shared information integrity, and a massive widening of the digital divide between the global north and south.
What's really vital to understand here is the timing and the framing of this. This report was dropped right before the inaugural Global Dialogue on AI Governance in Geneva.
Okay.
And the UN's explicit framing is that humanity has a very narrow, rapidly closing window to coordinate shared global rules before this technology becomes too concentrated and control is entirely lost. But their approach is unique. They are pushing a scientifically grounded framework. They want to focus on providing facts and inclusive global oversight rather than trying to prescribe specific binding laws that enforce compliance.
Okay, I hear that, but let's look at the reality on the ground for a second. How does this inclusive, scientific, multilateral UN approach actually survive contact with what individual nation-states are doing right now?
That's a great question.
Because let's look at the United States government. Earlier, you told me to put a pin in OpenAI's GPT 5.6 being locked behind a government-gated preview.
Yeah, bringing that back.
Right, because that preview is contingent on a June 2nd executive order. The White House is actively accelerating model standards in direct, closed-door coordination with Anthropic, KISI, and the NSA.
Well, this raises an important question, and honestly, it is the exact dilemma that is keeping enterprise tech leaders awake at night.
Yeah.
We are watching two completely incompatible models of global governance collide in real time. On one hand, You have the U.S. government increasingly treating frontier AI models like highly classified digital munitions.
Like weapons, basically.
Exactly. They view them as assets that require rapid export controls, strict government gating, and tools like Anthropic's controversial China location tracker just to keep them out of adversarial hands.
So it's a national security containment strategy.
Yes. But on the other hand, you have the UN and various international bodies attempting to build this broad multilateral framework focused on equitable access, preventing global inequality, and ensuring the technology doesn't just enrich 3 companies in Silicon Valley.
And again, just enforcing our neutrality rule here, we are impartially reporting on these differing global viewpoints. We are not endorsing either the U.S. national security approach or the UN's regulatory framework.
Absolutely. We're just looking at the operational impact.
Right, because looking purely at that operational impact, developers and enterprise labs don't really have the luxury of picking side in a philosophical debate. They're just trying to build and ship software, but they're trapped in the middle.
Yeah, they are caught in the crossfire.
The primary takeaway from all of this source material is that navigating these competing, completely incompatible regulatory frameworks is rapidly becoming the absolute hardest part of building AI.
It is entirely unprecedented. We've never seen anything like this.
So to synthesize everything we've just unpacked in this deep dive for you, we are looking at an industry that has finally achieved the staggering capabilities it promised.
Right.
We have autonomous agents like Fable 5 that can complete complex professional coding and design work completely on their own. And they're proving their worth on strict acceptability benchmarks like the Remote Labor Index.
The tech is there.
The tech is there. But to actually deploy those highly capable agents in a legacy enterprise environment is so incredibly difficult and so expensive that AWS has to launch a $1 billion brute force engineering strike force just to build the plumbing for their clients.
And every single ounce of that innovation and all the billions of dollars in capital is being forced through this rapidly shrinking bottleneck of conflicting global regulations, export controls, and massive geopolitical tension.
It is a phenomenal amount of friction. Like we said at the start, the rocket is violently shaking on the launch pad.
It really is. And, I want to leave you with a final thought to ponder. A scenario that isn't explicitly resolved in our sources today, but one that builds directly on this massive collision we've been discussing.
Okay, let's hear it.
Think back to Cisco, deploying AI agents to all 90,000 of its employees to act autonomously on their behalf. As we build these AI agents that make operational decisions in the background, executing tasks across global cloud infrastructure, what happens when one of those agents inadvertently violates a strict U.S. export control law, while it is simultaneously trying to optimize a workflow to comply with the UN mandate on digital equity?
Oh, wow. That is a legal nightmare.
When the agent itself is the one making the operational decisions and the regulatory frameworks it has to follow fundamentally contradict each other across international borders, who is legally responsible?
I mean, is it the programmer who set the initial parameters? Is it the CEO of the company using the agent? Or is it the cloud provider hosting the infrastructure?
Exactly. We don't have the answer yet. But given the sheer velocity of the capital and the capability moving into this space right now, we are going to find out very, very soon.
It brings us right back to the beginning. We have built an incredible engine, but the chassis wasn't built for this, and the traffic laws are written in 3 different contradicting languages. The friction is literally everywhere.
It really is.
Well, thank you so much for joining us on this deep dive. We hope this helped clear up some of the muddy waters of the AI ecosystem for you today. Until next time, keep exploring, keep questioning the systems being built around us, and we will catch you on the next one.